Hello, my dear student. Welcome again. I am Soham Jagad with your subject Science. I hope you all are fine and well and take necessary precaution at your home against COVID-19. So, we are studying chapter number 9, that is Force and Laws of Motion. That is also chapter number 2 of physics. We have total 3 parts in our science, that is physics, chemistry and biology, and we have little portion of environment science also. In this lesson number 9, till the time we have seen what is cause of motion, how we can change motion or say velocity of an object, what is inertia, what is cause of more and less inertia, what are the basic laws of motion, who gave these laws of motion, and we have seen first law of motion, that is also called as law of inertia, and second law of motion, and few example and some real life situation related to second law of motion. In the last lecture we have seen example number 9.1 to 9.4 and also derive how second law can be deduced to first law mathematically. So today's session we are going to start with numerical 9.5. What is the data given here? We have one graph. You can see this graph is velocity versus time graph. Now you know from chapter number 8 that the y-axis is velocity axis and this x-axis is time axis, and we always read graph as y versus x graph. Here we have velocity on y-axis and time on x-axis. So we will read this graph as velocity versus time graph, as we can read y versus s graph. And we have also write unit of both this quantity. Here time given in second and velocity given in centimeter per second. Remember, the unit centimeter per second is given here. That is not SI unit of velocity. So remember, we have to convert all the unit in SI unit. Here the velocity time graph of ball of mass 20 gram moving along the straight line on the long table is given in figure. So we have one figure, that is velocity versus time graph of 20 gram of ball that is moving along straight line. So what we have to find from this graph, how much force does table exert on the ball bring to rest. So we have to find force to stop this ball from velocity 20 centimeter per second to 0 centimeter per second. To solve this example, first of all we have to read this graph. So let me write given data first. We have ball of mass 20 gram. Okay, and we have to find force applied by table to stop this ball, which means at rest position. So let's read this graph first. Here we have velocity axis, start from 0, 5, 10, 15, 20 and so on. And here we have time axis in second, 1, 2, 3, 4, 5 and so on. I can derive initial velocity u. I can derive initial velocity u. That is, what is initial velocity? Initial velocity is nothing but the velocity at 0 time. So I can see from the graph at 0 second ball has velocity 20 centimeter per second. So I can write here 20 centimeter per second. Now, what is the velocity at rest? We all know that velocity at rest is nothing but 0 meter per second, or say 0 centimeter per second. To this initial velocity to final velocity, or say rest position, this ball takes time of 0 to 10 seconds. That is, time is 10 seconds. So now we have all given data with us by reading this graph. We derive initial velocity, that is 20 centimeter per second. What is the time for initial velocity? That is 0 second. Final velocity, that is at rest position, and time for this velocity gain is 10 seconds. So what we have to find here? We have to find force. Force exerted by table on ball. We have only one formula of force, that is F is equal to ma. Let's see, we have all values or not. We have F here that we want to find. We want mass for that. We have mass? Yes, we have mass. A, that is acceleration. We don't have acceleration, but now from past, for example, we know that we have formula of acceleration, that is V minus U divide T. V is final velocity, U is initial velocity and T is time. Now you can see we have all data with us, but here the data is not in SI unit. So first I have to convert this data into SI unit. So 20 gram mass is equal to 20 gram. So I have to convert this gram into kilogram. So what I need to do, I have to divide this with 1000. So I have m is equal to 0.02 kg. What I need to do, I need to shift decimal point to left side. Shift decimal point to left side. How many points? 3 points, cause I have 1000 in denominator. I hope you know this thing. I have decimal point here. So 1, 2 and 3. So I have now decimal point here. So I have 0.02 kg as mass of this ball. So I have m now. Now I have to convert this u into meter per second. I have u as 20 centimeter per second. So to convert this centimeter to meter, what I need to do? I need to divide this with 100, because we know that 1 meter is equal to 100 centimeter. So I get this in meter per second. This 0 will be cut and I have 0.2 meter per second as initial velocity. Now I put this value, m is 0.02, v is 0 minus u is 0.2 divide time I have 10 second. This second is already in SI unit. So I need not to convert this time in SI unit. So I have 0.02 multiply minus 0.2 divide 10. So I have 0.02 multiply minus 0.02. What I did? I shift this decimal point to left side. Why? Because I have 10 in denominator. So I will multiply 0.02 and 0.02. Now we know that 0.02 is 2 divide 100 into 0.02 is 2 divide, that is minus 4 divide 10,000. So shift this decimal point. Which decimal point? This decimal point left side by 4 place. So I have force is equal to 0.0004 Newton with this minus sign here. Don't forget to put this minus sign. What is significance of minus sign? Now we have seen from past example, this negative sign means friction force is opposing motion of this ball. So any force that is supporting motion will be positive, and any force that opposes the motion will always be negative. So here we have F is equal to minus 0.0004 Newton, as this force is opposing motion of ball. And remember one point I have told you in last session, whenever velocity is decreasing, whenever velocity will decrease, force will be negative, and when velocity will increase, force will be positive. So I hope you can remember all this point and correlate all this example with past example. Let's do one activity. What I do, if I will hit on this board like this, will some force act on my hand? Yes, I can feel some force. If I hit with some more force like this, will I hurt? Not much, but still I can feel some force on my hand. If I hit this board or wall with lot of force, will I get hurt? Yes, I will get hurt. Why? Because when I exert some force on this wall at that particular time, at that moment only, exert opposite force on my hand. So what will happen? If I apply force on anything, it will also apply same amount of force on me also. From this concept, we have our third law of motion, that to every force we have equal and opposite reaction force. So we have our third law of motion here. So with that we have third law of motion, that to every action there is equal and opposite reaction. Let's take another example. If I have a spring balance like this, spring balance like this, and I attach this spring balance to wall, and I attach another spring balance with this spring balance, something like that. And now if I pull this spring balance in this direction, if I pull this spring balance in this direction, what will happen? This both spring balance will show same reading, like say 10 kilogram. Both will show same reading but in opposite direction, and this wall will also exerted by force I have exerted here. So what will happen? I exert force here, so this spring balance shift this side. At that time also this spring balance try to pull this spring balance this side. So we have both a same reading in different spring balance, and at that time also this wall also try to pull this spring balance. So we can say that for each action we have reaction that is equal in magnitude and opposite in direction. Let's take another example. If I am standing here right now and I want to move, I intend to move, what I have to do? I have to apply some force on this earth or say floor. So if I tend to move, what I do? I apply force on earth. Let me try to explain you by figure. Consider this figure. I am standing here with happy face, and now I want to move ahead in this direction. What I need to do? I will look like this now. Something like this. So at that time, what I do? I apply some force on this earth or say this floor. I apply some force like this, some force. I try to push this earth. I try to push this floor back. And now we know that, can I move this floor back with my leg? No, I can't. So what happened? This floor also exert force on me with same magnitude but in opposite direction. So I move ahead. If floor was not that much heavy or not that much rigid, then I will not move ahead but the floor will move backward. But we know that that cannot be happen. So when we are walking, we apply force on floor but floor cannot move. So the floor exerts same amount of force but in opposite direction. So we can move on the floor like this. We can understand third law of motion by this example also. Now here we have to understand that this force is equal in magnitude, opposite in direction, and on different object. So this force which I indicate in green pen, that is exerted on floor, and the other force I indicate with blue pen, that is exerted on my leg or say on my feet. So the force exerted on two different plane. If I hit this board, one force exerted on this board and with similar magnitude and opposite in direction force exerted on my hand. So I hope now you understood how force are work, which means force are always in couple, force are always in pair. So we have couple of force. We can take another example. Let's take another example. We have one gun that is loaded with bullet. Okay, we have one gun loaded with bullet. When this bullet fire like this, what will happen? This bullet have some velocity in this direction and force exerted on bullet is also in this direction. At that time, by third law, this bullet exert force on this gun and magnitude of this force on bullet and magnitude of the force which is on gun are same in magnitude. So here I say F on bullet is equal to F on gun, which means F is equal to ma. I say mass of bullet, acceleration of bullet, mass of gun, acceleration of gun are same. So we know that mass of bullet is very small compared to mass of gun and mass of gun is more compared to bullet. So here this mass is low, so acceleration will be very high, but here mass is very high, so acceleration will be very low. You see in game or in movie, or you might shoot gun in actual, that when we shoot gun, the gun force backward like this. We seen in movie. So at that time, the holder of gun moves backward. That we called as recoil of gun. What we called as recoil of gun. So this recoil force, because mass of gun is high, mass of gun is comparatively high, so we need to remember that the force exerted on both the object is same, but due to mass different, acceleration of both object will be different. So bullet get more acceleration and this gun will get less acceleration. So I hope now you understood that force will be same, but due to mass, acceleration will be different.